Hey, I'm really interested in biotechnology and what it can do, and I want to go into industry and I want to work straight out of undergraduate. With the students in our labs, the ones I was telling you about that came up with their own ideas, the model the investors have created for this is that if the product works, they license it from the technology and they form an LLC around it, right? Kind of a typical startup model. And then they put the student as the CEO of that LLC. And the parent company mentors them and helps them and develops them in that business role now.
Welcome to the BioTalk Unzipped podcast, where we unzip the stories behind medical progress by sharing the latest and greatest advances in biopharmaceuticals and medical technologies in a fun, entertaining, and enlightening format. And now your co-hosts, Gregory Austin and Dr. Chad Briscoe. So you're both a professor, you're running a lab. How do you balance both of those worlds?
Yeah, that's a difficult question, and my wife probably has opinions on that. It's a lot of work, but it's fun work. I've never had so much fun going to work every morning and seeing the impact. You know, one of the reasons why I went into science in the first place was the potential to impact people's lives and to feel like I wasn't just getting a paycheck, but that I was, providing a benefit to society. And yet sometimes that can be hard to see because we get into this kind of rat race thing where we're getting the grant, publishing a paper, getting the grant, publishing a paper. And now I'm getting to see my research actually get out of that cycle, right? And get into the marketplace and have an impact. And the technologies that we're developing, we're partnering with other companies that have other use cases for it, and trying to see what people can do with this, right? And that's super exciting. The biggest thing we've done, though, is between the company and the university, we've created what turns out to be a fairly unique partnership between the university and the company. And so what happens is the company has licensed the technology from the university through the University Tech Transfer Office. And as part of that, they are providing a sponsored research agreement, kind of like a grant from a private entity, where they are funding further development of the technology on campus. And so because of that unique environment, right? And we're not going behind the university's back or anything. This is all through the normal channels. Everything's up front and clear. We are giving students a really cool, unique opportunity to do this research. We let students come up with their own ideas of new ways to apply this research. And they've come up with 5 different product types based on the same technology that I never would have thought of, that these students now get to pursue and try to develop it into a working product. It's really cool. They have to pitch to us both on a scientific level and a business level and convince us that their project is worth taking, but then they get to take it and run with it. And then any technology they develop goes through tech transfer again, and the company will license it from the university and be able to use that technology and to commercialize that technology. And so I think BYU's tech transfer has always said their main purpose is not to extract every penny they can from a company licensing the technology. They want to see this stuff get out there and impact people's lives. Yeah. And so with that paradigm, we've been able to set up this unique, mutually beneficial type system that also allows me to kind of combine the two, right? It's not my day job and night job anymore. They are intertwined, and we get to work together on these things as partners.
So do you expect or see some students wanting to become entrepreneurs, like right out of college and start working on this?
We do, more than ever. So I started at BYU 8 years ago. And at that time, I teach a big cell biology class, right? At that time, I would survey my students, 90% were pre-professional, dental or medical school, few vet school kind of thing, right? And then you have a smattering of students that wanted to go into graduate school, and basically no one that was ready to go out into industry and do stuff right away. That has swung now. I'd say it's probably down to 50, 60% that are pre-professional. And what's grown, we still have a group that wants to go get PhDs. That's probably grown a little bit. But what's grown the most are the students that say, hey, I'm really interested in biotechnology and what it can do, and I want to go into industry, and I want to work straight out of undergraduate. With the students in our labs, the ones I was telling you about that came up with their own ideas, the model the investors have created for this is that if the product works, they license it from the technology and they form an LLC around it, right? Kind of a typical startup model. And then they put the student as the CEO of that LLC. And the
Wow.
parent company mentors them and helps them
That's what I
and
say.
develops them in that business role now,
Hmm.
and allows them to take it. So we've had several really cool ones come out of that, including a women's health company and a forensics company, a pathogen detection company. And they're all former student led,
Yeah.
right?
Yeah.
And so it's
Yeah.
a
That's
really
cool.
cool, unique opportunity that they're getting. We like to say that we are creating CEOs in our labs is what we're doing.
CEO at age
Yeah.
23.
Yeah.
Yes,
That's
exactly.
What
wild.
an
But with
opportunity.
structure and mentorship around them,
Yeah.
right?
Yeah.
To
Yeah.
Yeah.
help them.
Got to incubate them.
Absolutely.
Yeah,
Absolutely.
exactly.
I, I just assumed these were graduate students, so I didn't realize they were bachelor level students coming up with these
Oh,
ideas and working in the lab. So I think that's even more impressive.
yeah. So BYU is an undergraduate focused university. We do have graduate programs, but most of the students working in our labs are undergraduate students. So that's where it's coming from for the most
Okay.
part.
Nice. Nice. Well, we'll be
Interesting.
sure to share some of those companies and their websites with me afterwards because I would love to highlight that. I think that's a great story to tell.
Sounds great. Many of them are early stage, right? They're developing the
Okay.
technology still,
Sure.
but
Sure.
Still going. Yeah,
hopefully they'll
that's
come
okay.
out over time.
Maybe we can help them with some funding.
Yeah, that'd be great.
Get it out there, right? Excellent. So, as someone deeply involved in both the science and technology, and we kind of talked about the AI side of things. Um, what do you think about as AI develops? Do you think that will change the way you do things, or will continue the same? Like, let's say AI starts to get better. Let's say you understand the black box more, and you still have your results outside of the black box. But do you think you will shift more to that, or kind of stay on the same course, hoping to see more of the mathematics leading this?
Yeah, I mean, AI is early, right? Early stage
Hmm. Hmm.
technology. I like to remind people what the internet looked like in the 90s,
Yeah, right.
right? A bunch of dancing GIFs on a page kind of thing. And that's kind of where we're at with AI. It can do these kind of niche things, but it's going to get more powerful as we move forward. The biggest thing that I think about isn't so much how it's going to change our analyses, because if we don't need AI, we don't need AI, right? If the signal is strong
Hmm.
enough, there's no reason to do it. AI will never be answering 4 plus 4 for us. We just don't need that for that,
Hmm.
right?
Hmm.
But where I see the biggest impact going forward is in medicine. Um, every diagnosis is really a complex interaction of multiple symptoms and genetic propensities and biomarkers and all these kinds of things. And that is something that we humans are not good at looking at, and AI is excellent at looking at, right? I imagine 5, 10 years from now, people will generally have a sequenced copy of their genome in their health records, right? And the AI is going to be able to scan that and look for propensities that are embedded in there, and then the labs that's been put into the records and the clinical manifestations described by the doctor, and be able to piece together a better diagnosis than we can do now. And with better diagnosis comes better treatment.
Hmm.
Um, so that's where I see the shift. And it will start gradually. I think our first phase is going to be a shift to where doctors are more and more using this as a tool, right? And then they're going to become more and more reliant on that tool, and their responsibilities will shift to perhaps more of the treatment, the hands-on doing things, right? Rather than the diagnosis. But I also think this is hugely important. Too often today, when you go to the doctor, they do what I call a guess and check model.
Hmm.
I've gone to the doctor and they're like, oh, well, that's interesting. Try this drug. And 2 weeks later, the drug's not doing anything. So then you have to set up
Hmm.
another appointment, pay another copay, go back in. The doctor goes, oh, try this other drug.
Mm-hmm.
2 weeks
Yeah.
later, same
Yeah.
process. In fact, I remember one case that happened. And the third one, he goes, huh, I really thought it was this. And so then it was it turned out to be a fungal infection on my foot, like an athlete's foot kind of thing. But the athlete's foot
Hmm.
medicine wasn't helping. And hopefully that's not too open there. And he took some scrapings and he went and looked under the microscope and he goes, oh, I know what it is. And he gave me the right medicine and it was cured. And I'm like,
Why don't we
why did
start
you
with
not
that?
do that the first time I was here?
Yeah.
Right? Why did you not carefully diagnose the problem and give me the right treatment?
Yeah.
Hmm.
And medicine needs to go in that direction because it's going to lower costs, make things faster and more efficient and better in the long run. if we can create accurate diagnoses. So
Yeah.
we're going to see that paradigm shift.
Yeah.
Do you think in the future that the genetic diagnostics will take a kind of a bigger role in, you go in, you get scanned somehow, and then all of a sudden, oh, you have this, and it's not a guess, it's a certainty.
To an extent, yes. But there are limitations there as well. So uh, I don't know if you're familiar with the movie Gattaca, but I love the movie Gattaca. Came out in the 90s. Gattaca, of course, is a sequence of DNA, Gattaca.
Right.
And it's about a kind of futuristic, somewhat dystopian technology society that is based very much on DNA sequencing. You should watch it. It's a great movie. And in the movie, they talk about genetic testing, and there's a scene where a baby is born and they prick the baby's foot and start reading out the potential diseases that this baby's going to have, right?
Hmm.
And it highlights both, I think, the power and the danger. The power is that having that information is hugely important. But one of the major themes of the movie, spoiler alert, is that that's not everything, that there's more to a person and you can't predict everything just on their DNA sequence. And so we have to be careful to not be overly reliant on those DNA sequences. Now, there will be cases where it is a very clear-cut genetic disease, but there will be cases where it's not. One of my major areas of research is heart development, understanding congenital heart defects and the genetic causes of it. Last I checked, it was a study in 2018. We could explain 35% of congenital heart disease cases with a genetic mutation. And that's including both inherited and sporadic mutations. Any way we can look at it and try to link it, 35%. Now, a percentage of those are because we just don't know the mutation to look for.
Yeah.
But a big part of that is likely that it was not a change in DNA sequence that caused that disease. A portion of those will be changes in epigenetic state, the gene regulatory state on top of the DNA, right? Another one will be environmental factors that have nothing to do with the genetics. And the last group will be a combination where a genetic factor doesn't mean you have a heart defect, but it means you're now susceptible to an environmental factor that may cause you to have a heart defect, right? Kind of like the tobacco addiction, right? Study. It doesn't mean you're going to be addicted to tobacco. It just means that you have a propensity for that. And so it's going to be subtle and it's going to be difficult in a lot of cases to try to parse those things out. So we need to look at all data types, not just genetic sequence.
Makes sense. So, Chad, it's a time once again for new news.
New news.
So recently, the FDA delivered approval to Lumicell's fluorescent system for highlighting residual breast cancer tissue. And so what happens is they use a fluorescent light system. It's a combo device. So you get injected with the imaging agent called Lumicite. And initially it's inactive, and then it begins to glow as it interacts with specific enzymes found around tumor cells. And simultaneously, a computerized handheld image probe scans for the surgical cavity created during the breast-conserving lumpectomy, and the probe will log any signs of residual cancer that's hidden among the healthy cells that many times gets missed, and they have to go in for a second surgery, maybe even a third surgery, which is obviously not desirable. So the Lumicite itself received approval from the FDA from the pharmaceutical side, and then the direct visual system hardware followed a parallel track on the device side. And so this is one of the first drug device combo products approved in over a decade to both go through the NDA and the PMA process, which is pretty cool. So Jonathan, what do you think about this breakthrough, and how do you see it maybe possibly working for different kinds of cancers beyond breast cancer during maybe resections of different tumors?
Excellent question. That sounds exciting. I've had loved ones, of course. I think all of us have who've gone through cancer treatments. And it is scary and nerve-wracking after that surgery to try to think about, did they get it all, right? Or am I going to have some sort of new tumor growing that I have to do another surgery, or this time metastasizes? Perhaps even because of the damage from the surgery, it gets into the bloodstream, goes somewhere else, and now I'm worse off than I was, right? And so that sounds wonderful. I would be very curious exactly how it's identifying the cancerous cells, because if it is a marker that tends to be more pan-dividing cell, for example, this could easily be applied to different kinds of cancers that you're doing a sort of solid tumor
Mhm.
surgery on. There, what would be the difference, right? And if it's more of a particular, breast cancer marker, then of course it's going to be more limited, and we'd have to find what those other markers are. But I'm excited for that technology. That sounds really cool.
Yeah, I believe Lumicell is now continuing into new research for other cancers using the same technique. So I think there's a lot of hope and potential for this to work in others as well. So I think that is really, it's great news for anyone who might have to go under the knife to go through the surgery, that this new technique is possible that would prevent hopefully anything worse happening in the future, including additional surgeries for resection.
Yeah.
Excellent. So, Jonathan, above and beyond, being a professor, managing your students, managing your labs, helping create CEOs, if there is any free time, which your wife may say, no, you don't. What do you do for fun or hobbies outside of those activities?
Yeah, there is not a lot of time for them right now.
Yeah, I
That's
understand
why
that.
it's good that this is my hobby. I love doing it.
Yeah.
It's not hard to go to work each morning, on both sides, right? Getting that research out, having an impact, working with the company. I'm finding the business side fascinating, but I'm also finding I don't know much about it, and trying to
Yeah.
learn
Yeah.
those things. The impact that I get to have with students, and seeing the light bulb turn on for them is awesome as well. But when I can, I tend to like to go outdoors and do things. Last year I got scuba certified,
Nice.
so now I
Yeah.
can scuba dive. Got to do that in Brazil a lot. Nice warm water,
Hmm.
really great. Not so
Mm-hmm.
many opportunities to do that here in Utah. We do live in a mountain desert, and so not a lot of scuba opportunities. But I like to get out and hike. When I can, I like to bike commute into work and ride my bike around, those kinds of things. So in Utah, you got to get outdoors. That's what we've got.
Hmm.
That's what we're famous for, and there's a reason for it.
Mm-hmm.
Beautiful,
Without a doubt.
beautiful. And so I'm curious if you can kind of help other young scientists or perhaps other students. You have a lot that come through, your department. What do you tell and what would you share with other students who are interested in genetics and biotechnology research, or maybe even becoming an entrepreneur? What would you encourage them to do? What advice do you have?
It's a great question. That is something we are actively grappling with right now. First of all, most of the students I'm talking to actually are pre-med students, but they're now wondering if they really want to do that.
Hmm.
And I was a pre-med student for the motivations that I think most people have. Hey, here's a job that's stable, pays me well, supports a family, and has a positive impact on people's lives, right? That's kind of every student comes through, and that's why they want to do it. And what I like to help them see is that some of these other career paths they're talking about can also do that. And there's
Mhm.
alternatives. And so if they don't get into med school, it's okay. In fact, they can
Mhm.
maybe even have a bigger impact on one of these alternative paths and talk about that. And the thing I tell them is first, you got to get in and do some research. You've got to get that lab experience. Your classroom has not prepared you for that.
Yeah.
And then secondly, this is your chance in your life to take a risk and go do something. Um, if the company that you try to start fails, you're okay still. You got plenty of time to recover and move forward, and you will be more competitive because you've had that experience, right? And so that's what I want them to see, is that there are alternative paths, and that these paths can be highly impactful, and that don't be afraid of failure. Go out, give it a shot, give it your best shot, and then come what may. There's luck, there's technological hurdles, there's all kinds of
Mhm.
things that might get in your way that have nothing to do with you, but
Mhm.
it's worth taking the shot anyway.
Absolutely. Persistence counts. And as
Yes.
Russ Wiener would say, embrace the fear.
Embrace the fear. I was just, several of your comments today, Greg, were right there with what I was going to say. But yeah, we've had that or some version of that statement has come through. The embrace the fear. Don't be afraid to take a risk. in I think every discussion that we've had with these. Well, it's a very successful group of people that we have on as guests, and I think that's that's certainly a theme that cuts across successful people, is to take the risk and go for it. So yeah,
Yeah, I mean, fear is good for us, right? It's a
yeah,
protective response that we have.
hmm hmm
But at the same time, we need to manage that fear and overcome that fear and check, why is that fear, and can I mitigate those risks and make sure that I'm not being reckless, right? Being reckless is different than taking a risk,
hmm
but
hmm
doing something that has a chance to be meaningful and impactful, even though there's a chance of failure. That's okay. That's a low
yeah,
risk.
yeah, for sure.
Yeah, absolutely. So that fear will kind of drive us into our comfort zones and keep us from taking chances and doing things that would have great growth opportunities for sure.
Hmm.
So,
Yeah.
and I'm curious, you said these, these students coming out, they become a CEO, they have this mentorship program. Are those, is it somehow tied to the business school? Are there people with, business and accounting and marketing to help? Because all those things have to come together, besides the technology, right? First that's got to work, but then you have to sell it, right? Is
Right.
that part of the mentorship?
There are, and it's growing. My
Nice.
co-founder, Tim Jenkins, who you mentioned at the top of the show,
hmm
teaches a class called Bioinnovations. And in that class, he has two parts. The first semester, they look at, what does it take? What do you need to do? How do you raise funds? How do you validate your technology? All of these kinds of things. And then in the second semester, just those students who have their own projects stick around, and they really help get them that mentorship and those resources. We also have a great entrepreneurship center, the Rollins Center here at BYU, uh,
Nice.
and we've had lots of conversations with them. They're typically built around kind of a software app kind of startup, right, at the moment.
Right.
hmm
But they are very interested in partnering with us, and we're very interested in partnering with them to try to tweak some things into a biotech model. And what we're finding, one big thing is you cannot do biotech in your garage. It's not legal. And so you're
That's a
not
good
allowed
point.
to do it. Some bioinformatics applications you could, right? The data analysis stuff, but you're going to need a lab. And often in the university setting, what that means is you need a faculty student partnership where there's a faculty mentor that's got the lab space, got the funds, got the know-how, and a student who's got the idea and the drive and the time to pursue this. And when they work together, that's when it is most successful, right? And so we're
Awesome.
working with the Rollins Center to try to create that faculty student partnership model, so that they can get the resources they need, but also be able to take this idea and run with it.
It's phenomenal to see what a lot of universities have done. I mean, this is really exciting to hear what BYU is doing in innovative ways of not just learning, but also preparing students, preparing young people to be in the world and be successful. Right? Not just here's your degree and good luck. And we,
Right.
and at the same time also supporting professors, right? Where the funding sources are changing. You guys can't just rely on grants, right? That's
No.
not going to support everybody out there as I think as it did, 30 years ago. So really hats off to BYU and so many of these institutions that are finding new ways to make it work. So
Yeah, I
that's really
think in
great.
some ways
Yeah.
there's a lot of introspection going on in higher education with the student
hmm
loan crisis and kind of a popular culture backlash against higher education, and raising the question of what value are you actually adding to me as a student, right?
Yep.
hmm
And honestly, I think it's needed. This may be a hot take, right? An unpopular opinion, but perhaps in academia, we've gotten side railed a little bit where your prestige comes from your research, not your students. And the students
hmm
are starting to feel that. And they're starting to say,
Mm-hmm.
hey, wait, what about me? Right? Where do
Yeah.
I fit in
Yeah.
this? And we're having to respond and say,
hmm
here is the value added. This is what you're going to gain
Yeah.
if you come to my university. This is how I'm going to prepare you to have a more fruitful career, and have that training that you need to be successful, kind of thing. And I think it's healthy. I think it's good.
Yeah,
Yes.
it is, and
Agreed.
that may be an area where industry, by the nature of the beast, when my people are successful, my department is successful. and therefore it's sort of, I can always promote them and not worry. At least I don't worry about myself so much, right? But I think, like you
Right.
said, in academia, it's got to be, the old drivers of publish or perish
Mm-hmm.
and all this are always about, kind of you so that you can succeed and frankly just survive, get your tenure, keep your job.
Right.
So that's, yeah, but it does need to be about the students.
Well, and
Yeah,
it's
yeah,
difficult for me because this foundational research that we're conducting in the universities that don't have a direct product related, but builds that foundation of knowledge we need
yeah,
to develop
yeah,
those things
yeah,
is
yeah.
hugely important.
Mm-hmm,
But
mm-hmm.
in some ways, with decreasing funding rates, increased pressures on publishing, et cetera, that we're having, it's becoming harder to focus on that and the secondary one of creating tomorrow's stars, right?
Right, right.
And
Mm.
training these students up and helping them be successful, not just tools for my success
Mm-hmm,
in
Yeah,
the lab.
mm-hmm.
I think that's hugely
Yes.
important, and it's encouraging to hear.
Yeah.
And so, because I know a lot of, young people graduating from high school, and they're just like, I don't think I want the debt. I'm just going to try this, or maybe I'll just go to junior college for a little bit and get my associates and just get out there and try to make some money. Um, and there's some cases where that's fine and that'll work out well for them. And there's other cases where they're creating a ceiling, for them
Yes.
to not be able to really to grow beyond what society and the corporate situation is going to let them do.
Yeah, I just saw a stat yesterday, I think it was, that in a typical year, 50% of graduating high school seniors turn in a FAFSA form, indicating, that they have an interest at least in going to college. And this year it was down, I think it was 37% was the
Oh,
number that
wow.
put it in. So that's a
Wow.
13% drop
Wow.
off.
Hmm. Hmm.
And that's big,
Yeah, that is
right?
huge. Yep.
And that makes you wonder. It's not that college suddenly got cheap and they don't need federal aid.
Mhm.
So clearly, students are choosing to go to junior college or somewhere else into the workforce. Some of them will do that for a couple of years and change their mind, and they'll get
Mhm.
there. But again, it's a wake up call to us in education on what are we doing. And I hope we've created a unique model with this cool partnership between our company and the university of
Indeed.
saying, at least for a certain niche of students, here's something that we universities have not provided before that we can provide, and we're going to start providing.
I think you're already seeing that with the percentage of students who are kind of changing, maybe not going to medicine, which is
Mm-hmm.
fine. Not everyone, who starts in medical school ends up, being a doctor or what have you. But it gives other opportunities to be in the field and really enjoy biotechnology without necessarily, being a doctor and still being a business person and a researcher and so forth. So I think it's great.
Yeah. I grew up in the Silicon Valley in California in the 80s and
Mm.
90s, right?
Wow.
And where I see biotech right now is like technology software in the 80s and 90s, right?
Mm-hmm.
We're
Mm-hmm.
just getting kind of for software, it was the PC, right? The transistor that led to the personal computer that kind of
Mm.
created that sea change and allowed it to explode. I think now with DNA sequencing technologies and the genetic engineering technologies that we have, we're seeing that same kind of transformational technology come about that allowing the field to explode, the industry to explode. And the students are seeing that and they want to be part of it. And so it's an exciting place to be.
That's excellent.
It is. Yeah.
So Chad, do you have any final questions before we wrap up?
I was curious. This is kind of stepping back a little bit, but I was curious with it Wasatch. Have you gone down the regulatory pathway yet? Is that a direction you've yet had to tackle? Because that's a whole nother space. It's a space I live in all the time, and it's interesting, but it's another heavy lift.
So our year and a half has been spent on finalizing the technology. Now we're moving into that stage,
Okay.
but we
Yeah.
recognized that early on. So
Mm.
two of our co-founders actually have a background in CLIA
Oh,
certification,
good. Yeah.
CAP
Yeah. It's good.
certification.
Mm-hmm.
And in fact,
Mm-hmm.
one of the things I told you, we've been partnering with other companies, with
Yeah.
people that say, hey, I'm interested in looking at DNA sequencing or epigenetics or copy number variants, anything that we can get through our
Yeah.
kind of core technologies.
Yeah.
And one of the things we can offer them is that we have staff trained on doing CAP and CLIA certification.
Okay.
And should your product go to that stage, we can help with that
Mm.
as well.
Yeah.
And so our facility has been built to all the standards that we need. They've been advising the technology development to make sure that it's ready. And now we're moving into the CLIA certification studies on a couple of our methods that we've developed with this to be able to go through that process. So we're aware of it going through it. We're also aware of the FDA wanting to change LDTs and all this kind of stuff.
All the LDT stuff. And then if you go to Europe, right? So then that's a whole nother thing, but that's probably a partnership if you head to
in
Europe,
that case, likely. Yeah.
And
so, but yeah, so we are aware of these issues and kind of keeping our fingers on that pulse as things move forward and change.
Yeah. Phenomenal. Good for you guys.
That's great.
Yeah.
Smart to pre-plan like that. Be prepared.
Yeah.
Excellent.
But yeah, I really enjoyed the conversation, Jonathan.
Same.
Really appreciate you taking the time to be with us today. I learned so much, as I do in every one of these conversations.
Same.
And just appreciate it. Thank you.
So thank you. It's been fun.
Yeah.
Sorry. For our audience, what are the best ways to find you online? Is it LinkedIn? Is it your lab link? What are the best ways to reach you?
You can find me on LinkedIn. You'll want to check the spelling of my name in the show notes because it's an alternative spelling of Jonathan, right?
Makes it easier to find you.
Yeah,
Right.
it makes it
There you
easier
go.
to find me if you know the spelling.
Right.
There's
There you
fewer
go.
to sift through. And then the company, the best way is through wasatchbiolabs.com. It's got a portal that explains some of the stuff we do. It's also got a way that you can reach out and say, hey, I want to talk to someone about this. We found that each case is unique, and it's best to get either me or Tim, one of the scientific PhD holding leaders, in on that conversation early on. And we're really going to sit down and see if our technology can help you out and what benefits it can provide. And, we're careful with confidentiality and proprietary technologies, all that kind of stuff. But we've found, we can't do it all. We can't think of it all. And so by putting that out there and saying, hey, we had our technologies that we're interested in that we developed this for, but we want to see what you can do with it, we can magnify the impact of this technology and help other people in their sphere, the disease they're interested in or the method they're looking into, and really help them out as well. So we want to partner with people. You can reach out through the website.
Excellent. And as we mentioned at the top of the first episode, is that we will make a $100 donation to the Rainforest Trust in honor of Dr. Hill, his favorite charity. So please, if you want to learn more about the Rainforest Trust, check out the show notes, and you'll see a link down there. In the meantime, again, Jonathan, it was fantastic having you on the show. It was a great opportunity to meet you, learn about the nanopore technology and the exciting work you're doing. Very excited about the potential diagnostic hopes for Alzheimer's research, and we'll continue to follow that as it moves forward in the process.
Yes, thank you again. It was a wonderful opportunity. You guys are great hosts. It's fun talking to you.
Thanks so much, and take care. Have a great afternoon.
Ciao.
Ciao. Até mais.
Thank you so much for listening to this episode of BioTalk Unzipped. Please be sure to like, subscribe, and share.